Hello there, Mr. Sutton here, bringing you the Algebra 2 1-3 Part 1 homework solutions. This one dealing with modeling linear functions, specifically working to write equations of lines from tables and also comparing linear models. For this problem, they want us to use this graph here to write an equation of a line and interpret the slope. So we have this gasoline tank sort of graph going on, and the y-axis is fuel in gallons, x-axis is distance in miles. Now, to get the equation of a line, we need the slope and either a point or a y-intercept. Let's get the slope first. So we're going down 3 and over 90 from the starting point here. So we can write negative 3 over 90. And the y-intercept, actually, they gave that to us. If we look closely here, let's see, these grid lines are going by 2's, so this is going to be a 12 up here. So we'll use 12 for our b value. Since we have the slope and the y-intercept, we're going to use y equals mx plus b, that form of a line, slope-intercept. So I can write y equals, now let me just reduce this slope to negative 1/30 x, and then plus 12. Now in terms of the slope that they want us to interpret, so the top unit here is gallons, the bottom unit is miles. So this is gallons per mile that this is changing, and it looks like it's going down. So it looks like that we're going down by, our fuel is decreasing by 1/30 of a gallon for every mile driven. Right, for this problem, they want us to use the graph to write an equation of a line and interpret the slope. So to get our line equation, we're going to want to get our slope, and if we can get it, the y-intercept, otherwise we'll use a regular point. So for the slope on this one, they gave us these nice little convenient arrows. We're going up 100 and right 2, so rise over run. We've got 100 over 2, which we could reduce to 50, but we'll just do that later on. Now for the y-intercept, the b value, our grid lines here are going by 50s, it looks like. So if I'm 50 down from 150, that looks like 100 right there. So that's my b value, 100. So using then y equals mx plus b, I can write y equals 50x plus 100. And now to interpret the slope here, this 50, the y units are dollars, the x units are weeks. So this is $100 for 2 weeks or $50 for 1 week. So if this is a savings account, that must mean that our account balance is going up by $50 per week. For this problem, we're trying to figure out an equation of the line represented by this graph. So let's first figure out the slope from the graph. We are going, it looks like, up 2 over 10. So we've got 2 over 10 for our slope, and we'll reduce that in a little bit. For the y-intercept on this one, we're crossing the y-axis at 0, so that's our b value. And since we have both the slope and the y-intercept, we can use slope-intercept, y equals mx plus b, to write this equation. So we can turn our slope into 1/5, so that's 1/5 x plus 0, which we don't need to write. And they also wanted us to interpret the slope. So the vertical units here are dollars, that's our tip dollars. The horizontal, the x values, are the cost of the meal. So this is talking about how the dollars of the tips are changing as the cost of the meal changes. So this is saying that our tip is going up by 1/5 of a dollar, or 20 cents, for every dollar increase in the meal. And that makes sense if it's like a 20% tip, which sounds pretty typical. For this next problem, we have a swimming pool sort of chart going on here, and we're trying to write an equation of the line represented in this graph, and then interpret the slope. So let's first off get our slope. We need that regardless of what type of a line equation we're going to do. So we've got 2 points, 3, 300 and 5, 180. I'm going to use my slope formula to figure those out. I can't really eyeball this one, so I'm going to use the full formula. So we're going to have in our numerator y2 minus y1, that's 180 minus 300. And then we're going to have x2 minus x1, so 5 minus 3. That's going to be negative 120 over 2, which I can then reduce to negative 60. Now, normally I would look to see if I can find the y-intercept on this, and it looks like it's like 400, maybe 470 or 480. I'm not really 100% sure. So because I'm not sure about the y-intercept, I'm going to use the point-slope form of a line instead of slope-intercept. Let me use y minus y1 equals m times x minus x1, because I can get a point off of here pretty easily, and I already have the slope, but I don't have the y-intercept. So I'm going to use my first point in this form. So we'll have y minus 300 equals my slope I just found of negative 60, and then x minus 3. And then if I want to just simplify this to be slope-intercept, I don't really have to because they didn't specify that, but I'm going to. Let's distribute this negative 60. So we have negative 60x, and then negative 60 times negative 3 is going to give me 180. If I add this 300 over here to get y by itself, 180 plus 300 is giving me 480. So I was actually, my gut was right, it was 480, but we didn't know that for sure. So now interpreting the slope of this thing, what does the slope represent? So the y values are the cubic feet of our swimming pool, our volume, and then the time is the x values. So the volume of the swimming pool is changing at a rate of negative 60 cubic feet for every hour. I guess we could say, if we're being more specific, the volume of the swimming pool is decreasing by 60 cubic feet per hour. Maybe they're getting rid of the water in preparation for the winter. Who knows? For this problem, we have a lot of words going on here. So you're thinking of buying a phone from one of two cell phone carriers. The table shows the costs of the phone and the service for different numbers of months for carrier A, and then the total cost of the phone and after X months of service for carrier B is just represented by this 55x plus 300 equation. So we have information from A in one form, information for B in another form. So based off this, which carrier charges less per month, and after how many months of service are the total costs going to be the same? All right, so let's deal with our first question, who charges less? If we're talking about charge per month, that's going to be the slope, because if you see how much the total cost is increasing after so many months, that's giving you your cost per month. So in order to figure this out, we're going to need to compare the slopes of our two carriers. The slope will be pretty easy to get out of carrier B, because this is already in slope-intercept form. So we'll deal with that in a moment. But for carrier A, it's all in table form, so we have to do a little more work to find that slope. So I'm going to write that my slope is going to be basically y2 minus y1 over x2 minus x1. We're going to just take 2 points out of here and use them. So I'm going to use the first 2 points. So we're going to have 650 minus 500, so that's the change in y, divided by 6 minus 3, the change in x. That's 150 over 3, and that's going to give us 50. So that's $50 per month that we're being charged on this. Now, before I compare this to the slope of carrier B, I know that I'm going to need the equation of the line for carrier A just for this later part in the problem about figuring out where the costs are the same. So while I'm already thinking about the slope, let me just plug this into y equals mx plus b to get the equation of the line. Now you might be thinking, well, we don't have the y-intercept. We don't know what the cost is at month 0. But let's just think about this. If you're changing at $50 a month and you're at $500 on month 3, if we go back in time 3 months to month 0, that's going back $150 to give us $350. So for my equation then, I can write y equals 50x, that's our slope, plus we said $350 for the y-intercept. Now just answering this first question here, the slope of carrier B is just this slope of the slope-intercept here, the 55. And since that is bigger than what we got for carrier A for the slope, that means that carrier A is actually charging less. So that's good information to have. Now, that doesn't necessarily mean that carrier A is going to cost you less money no matter what time you're looking at, because although carrier A costs less in the beginning, they might be more expensive right off the bat. Like they're $350 to start with, and carrier B, their y-intercept is 300, so it's actually cheaper to start with them. So let's go ahead now, and to figure out where these are the same cost, we need to set them equal to each other. I'm going to use the substitution method. So we have y equals 50x plus 350, and y also equals 55x plus 300. So if I replace one of these y's with the equation for the other line, I can solve this thing. So let me take this 50x plus 350 and substitute it for this y right here. So I've got 50x plus 350 equals 55x plus 300. Now if I subtract 300 over to the left, that'll give me 50. Subtracting 50x over to the right gives me 5x. And then dividing both sides by 5, we get x equals 10. So that's 10 months that it takes for these costs to come out the same. For this next problem, we have you and a friend signing up for a new volunteer project to increase your service hours. The table here is showing total number of service hours for you after a different number of weeks on the new project. And then your friend, we have some different kind of information. They initially have 8 service hours, and they spend 2 hours on the new project each week. Basically, we want to figure out, based on this, who initially has more service hours and who volunteers more hours per week, and after how many weeks do you and your friend have the same total number of service hours. Okay. So let's start off by getting an equation for how many hours you've spent. To do that, we need a y-intercept, which we don't have initially, but we can get it pretty quickly. We also need a slope. The slope would help us get the y-intercept. So to get the slope, we're just going to take 2 points in this table and use our slope formula. So we have y2 minus y1, 20 minus 15, over x2 minus x1, 6 minus 4, and I'm calling this m sub y. This is your slope. Y stands for your. So now we have 5 over 2, which if I wanted to, I could make that 2.5 to make it a little bit easier to work with. Now for the equation here, using y equals mx plus b, we've got a slope of 2.5, but we don't know how many hours we had at week 0. So what we're going to do is use our slope to work backwards. So if we go backwards by 2.5, 4 weeks, 4 times 2.5 would take us 10 hours back in time. So that would mean you would be starting with 5 hours for your initial number of hours. So we can then write for our equation y equals 2.5x plus 5. And this equation will come in handy later on anyway. Now for your friend, they sort of spelled it out here. They spent 2 hours per week on the project, so we can write y equals 2x for your friend. That's their slope is 2. And then they initially had 8 service hours, so that's their y-intercept plus 8. And again, the F's here stand for friend. Okay, so a lot of questions here. Who has more service hours initially? Well, your friend has 8, you have 5. 8 is more than 5, so your friend has more hours initially from doing whatever. Now, how about more hours per week? Well, you have 2.5 hours per week. Your friend has 2. So you're actually volunteering more per week than your friend. And then where do they equal the same number of service hours after, what did they say, after how many weeks? So basically, we can use substitution method. We have y equals 2.5x plus 5, and y also equals 2x plus 8. So I'm just going to substitute 2.5x plus 5 for this y right here, because they both equal y, and set that equal to 2x plus 8. So solving this equation now, I can just subtract 2x from both sides. That's 0.5x on the left. And then subtracting 5 gives me 3 on the right side. Dividing by 0.5 or multiplying by 2 accomplishes the same thing. Gives us x equals 6. So after 6 weeks, the two of you have the same number of hours.